But anyway, thank you, Orv, for showing up. I got a quick report on what I say we accomplished, what the A team accomplished. We had Chris and a group of guys go up to Toro Peak. We on November 4th, we had a lightning storm go through Southern California, and it wiped out our microwave back down to Edom Hill. We had Dale go up and WA6NVW and KS6F and restore the AREDN system on Toro Peak. So it was a very successful trip yesterday, both for AREDN and also for the Papa system, restoring Papa 7. The darn system got a direct hit on the tower and blew the antenna right off the tower. So it's the only other thing I have is I want to remind the members that are watching. Let me turn my radio off in the background here. Sorry about that. We're making some changes regarding the luncheons and the fiesta, and we're requesting payment to be made through the Papa website on PayPal. That'll be your RSVP for the San Diego luncheon and again for the fiesta. So if you haven't yet, don't wait till the last minute to make the RSVP, especially for the San Diego luncheon. We've negotiated with the manager. He's given us a great room with a great buffet, and includes the tip and the taxes for $20. So if you plan to go to the San Diego luncheon, please take care of it here in the next week or so. Don't wait till the last minute. That's about it. Once again, I'd like to thank Orv for joining us. And again, we're trying to do, the Papa system's is doing their part in supporting AREDN. Orv, if you're not up to speed, we've provided sites at Toro, San Marcos, and there's one other hill that I'm forgetting. God, there's 3 hills that we have AREDN in San Diego. But I'll give it back to Dave, KK6M, WD6XNA.
Okay, well, thank you very much, Cecil, and very good updates. Yeah, I remember that lightning storm was pretty amazing. I'm glad we got away without too much damage from that. Okay, I'm going to turn the meeting over to Norm so that he can give a little introduction to our speaker today. Thank you, Orv, for showing up. Really appreciate it. I'm sure we're all going to learn something great about the AREDN system. So Norm, introduce your speaker, and then we'll hear him, and then afterwards, after the speaker, we'll do questions, and then after that, we'll adjourn to the parking lot, and you guys can all get unmuted and chat among yourselves. So that'll be kind of the way we'll run things this morning. So Norm, take it away, introduce our guest, and thank you so much for showing up, Orv.
Well, Orv is the one I heard about AREDN from first many years ago, and he's my go-to person for how to do things. He's got disciples that he's training all over the place. So I've got some local help, and I've got a little AREDN node, and I'm adding to it. And I'm now getting up to the point where Orv had to say, and with this one, don't walk in front of it. I actually woke up last night thinking about that, Orv. So it's very large dish. What's the gain on it, Orv?
25 dBi.
25 on 3 gigs. Yeah, you don't want to walk in front of that. It's a 600 milliwatt transmitter, but with that kind of gain, you don't want to walk in front of it. Okay, Orv, I'm going to turn it over to you. I think we are recording.
Yes, we are.
We are. And you've got the floor and you've got the spotlight. And you can
All
share
right.
your
Thank you,
screen.
Norm. And thanks for the invite. I'm looking forward to it. Let me see if I can share the right screen. It's always an adventure. How's that? You see the first screen? First slide?
Yes, I do.
Okay. So we're going to talk about using AREDN software to create a ham radio network. There's all my credentials there, big deal. First thing I want to talk about is data rates. Not talking throughput, I'm talking modulation rates. If you've ever had a 56 kilobit modem, you knew you didn't get 56 kilobit end to end. Packet radio is 1200 baud, and with the modulation scheme they use, 1 baud is 1 bit per second. In modern terms, that's 0.0012 megabits per second. It wasn't especially fast in the 80s, and it hasn't improved any. Pactor 4, which is actually illegal in the United States, can do about 5 kilobits per second. VARA is a software modem that's used on both FM and HF. And with the right radio and interface on FM, you can do up to about 25 kilobits per second. These network links, though, we're putting up point to point, can be more than 100 megabits per second. But again, that's throughput, not end to end, or that's modulation rate, not throughput. So the software, as of today, was actually derived from the OpenWRT open source router software, which was derived from the Linksys WRT 54G software, which came from the Linux project in the late 90s. It now supports 4 different brands of equipment, 70 different models across 4 ham radio bands. And if you happen to be in an RF hole when it comes to network connectivity, you can tunnel from your node to another one that is on the network and get connected that way. One part of the secret sauce for AREDN code is they've figured out how to move the radios in the wireless access points out of the unlicensed Part 15 channels down into the adjacent Part 97 ham radio only channels on 2 gigs and 5 gigs. And you can imagine how much quieter it is there. That alone makes performance just tremendously better. 802.11n is the protocol they use, and it knows about MIMO, which is multiple input, multiple output. In our case, 2 polarizations and 2 radios, vertical and horizontal polarization, transmitting simultaneously. And because not all hams are versed in the intricacies of setting up a network, the AREDN code provides a DNS server to give you IP addresses, or node names, I should say, DHCP service to give you an IP address, and also does through route broadcasts, route discovery, and routing information. So you don't have to figure out how to get to the distant destination. And all of those put together makes it pretty easy to get these running. So once the software is loaded in them, we call them nodes. Fortunately, nowadays, there are few, if any, hardware mods you have to make, which makes the entry level a lot easier. There are the 4 different brands. Ubiquiti and Mikrotik are by far the most popular ones. TP-Link makes some excellent gear. It's just not that popular around here. I don't know why. And GL.iNet makes a line of travel routers that AREDN has now supporting, and they're useful for little niche projects. And when they're all loaded with AREDN software and they come up here each other, they make a TCP IP network. Okay, where were we? I don't know where I got cut off, but once the software is loaded, we call the wireless access points nodes. And there's few hardware mods. You can get started with off-the-shelf hardware, which really lowers the bar to entry. Those are the 4 brands that AREDN supports. Ubiquiti and Mikrotik are the most popular ones. TP-Link is not as popular. I don't know why. It's excellent gear. And GL.iNet makes a line of travel routers that AREDN is now supporting, and they're useful for specific uses. And when they all come up together on the air and they hear each other, they create a ham radio TCP/IP network like the internet, only smaller and slower. You have to kind of consider them like handy talkies. They're only 600 milliwatts, low power, and pretty much limited to line of sight. There's no knife edge refraction like you might see on 2 meters. So they usually communicate through a hilltop radio site. Handy talkie talks to a repeater, and your node talks to a node on a hilltop. And because of the OLSR routing protocol, even if your node hears multiple hilltops, it will always choose the strongest one. So there's no point in running an omni antenna. You might as well focus all your RF in the direction it's going to be communicating with anyway. This is an old slide. I've updated it a couple times as the hardware improves, but the one tree is still true. They don't do well with vegetation. So you've put up this great ham radio network that stretches all over the Southern California, but it's just a network. It doesn't do anything. All you use it for is to get to things you want to use, and those are the services. And here's a bunch of them here. Pretty much anything you see on the screen and anything else you can think of subject to the Part 97 regulations. So I'm going to talk about some examples of services. We've used all of these from time to time in Southern California. We're not, in my area anyway, using all of them now, and I'm sure there's services used elsewhere that we're not using here, but this is just a sample. So communications hubs are kind of like Slack if you've used that. Mattermost and Rocket Chat are the open source wannabes. They're quite good. They all support text and pictures, unlike the old IRC. Multiple channels can be made. All of them have access to their hub via a web browser, but they also have applications for all of the OSs there. So here's a shot of our Mattermost server. This is kind of interesting. Eric, KG6WXC, was camping with his family out in the high desert when the Ridgecrest 7.1 earthquake hit, and they got bounced around in their tent quite a bit. The next morning, he drove over and took a picture of the surface rupture and showed it to us on Mattermost. Now, the ham radio network doesn't extend out there, but we have 2 Mattermost servers, one on the internet, one on the mesh network, and they're linked together. So Eric, with his Mattermost app on his phone, was able to share it with us on our mesh network Mattermost instance. Voice over IP, I mean, that's another application. This picture is getting quite old. This is pre-installation, old Cisco phone on the left. And at the time, we weren't quite up to speed on open source VoIP PBX solutions like Asterisk and Free PBX. So we purchased a turnkey VoIP PBX. This one's from Grandstream. It's under $300. Has more resources than we'll need. And here it is installed in the repeater rack. This happens to be on Sulphur Mountain, south of Ojai. At this point in time, that PBX supports, I don't know, about 30 extensions. Most of them are hams, but everywhere we push out the mesh network to a served agency, we give them a phone and an extension. And the PBX supports, you know, conference calls, call waiting, call forwarding, everything you'd expect from a modern phone service. And because it's a Grandstream phone or a PBX, we encourage people to use Grandstream phones on this PBX. And there you can see that I missed a call. and somebody left me a voicemail, just like a regular phone. This was the next PBX we pushed out. This happens to be a Raspberry Pi 3, not a very impressive photo, but it's running free PBX, and this one's on Verdugo Peak. The network extends over there, and the two PBXs are trunked together, so you can make calls between them. Out here in Ventura County and Western LA County, we have 2 or 3 more PBXs we're going to trunk together, and there are a few other down farther south, and we've sort of talked about trunking them together, but too many things on the plate. So collaboration servers are like what you see the gamers use in movies and TV to keep their teams coordinated. Some examples are TeamSpeak, Mumble, TeamTalk. There's a list of a couple dozen of them on Wikipedia. They all share a common set of features: voice and video chat, file sharing, desktop sharing. I'm sure there's other features. We chose TeamTalk because it's one of the few that isn't encrypted. So we got to avoid that whole Part 97 obscuring meaning thing. Supports chat rooms, many to many, one-on-one chats. You can set up as many channels as necessary. You can use the speaker and microphone on your laptop, or for really good voice quality, use a USB headset. All the conversations are full duplex. You don't need to wait for the guy to time out the repeater before you can talk to him. It's much more natural. You can even interrupt somebody. And if you have multiple channels configured, you can have simultaneous conversations going on. Each voice channel takes up about 30 kilobits per second when the person's talking, and that's nothing on a mesh network. And the codecs in TeamTalk will always try to shift up to the highest quality they can, which is typically excellent quality. This is not your grandfather's 300 to 3000 hertz communications grade channel. It's quite good. And you can use any key on your keyboard as push to talk. We usually use left alt, but it's your choice. Also supports Vox or open mic, a nailed up connection end to end. Might use that in an emergency situation. We have a Wednesday night net, and I'll close the office doors, put my USB headset on, put it on Vox, put my feet up on the table, and just have a very natural conversation. Here's a picture of the TeamTalk app. I think this is Windows, but they all look the same. On the left is everybody that's joined in. When a person's talking, their call sign is highlighted in green. When they lift up on push to talk or otherwise stop talking, it turns to yellow. So you can see that Dave KM6FQ was the last one who talked. It's 4 tabs across the top: chat, video, desktops, files, and you can see a few of the chats there. And this is the video tab. I don't find that video adds a lot to a conversation, but from time to time, we do have everybody fire up their cameras to do a stress test on the network and the server. We typically configure 640 by 480 video with maybe 10 to 15 frames per second, which results in a video stream from each camera of about 100 kilobits per second. So you can see there's 7 guys there, 700 kilobits per second up to the server and 700 kilobits back, at least. And that kind of a load on the server was about 10% CPU utilization and 10% network utilization in the server. The mesh network itself in our part of the Southern California can carry, I don't know, on a good day, 3 to 5 megabits per second. So it supports this quite easily. We also push this app out to any served agency, so we can set up special channels if need be, Fire Camp 1, Base 1, whatever, Red Cross 1. And those can be created by any admin or any user that you give privileges to. So this is, I want to talk a little bit about this one. The AREDN software gained the ability to accommodate more than 2.4 gigahertz in 2016. And in late 2016 and all through 2017, we were pushing out a backbone across Ventura County, and every hilltop that we got a backbone connected to, we added a user access point so people could jump on the backbone and move around. At this particular site, which happens to be Sulphur Mountain, just for grins, we threw up an old junker camera. It's an IP camera, but nothing fancy. It was just a bullet camera, fixed focus. And it was fun to watch it occasionally. In September of 2017, Ben AI6Wire, who's another tech specialist, sent me a link to an article on how to stream webcams to YouTube. He says, hey, see if you can figure this out. You might be able to use it someday. Well, I messed around with my test driveway camera and got it working and said, here, isn't this neat? And put the information away. Well, less than 8 weeks later, the Thomas fire broke out near Santa Paula, California, and Ben pinged me, said, hey, we have a camera up there, don't we? I said, yeah, different brand camera, different model, different OS, but I got it working in pretty short order, and this is what we saw. A hot, windy, dry day, howling winds, and this is what we saw, the fire getting ready to crest. We streamed this for about 2 hours until we lost power to an intermediate website. At that point in time, we didn't have backup power pushed out everywhere, in fact, hardly anywhere. After we lost the video, the fire came down the hill there. You can see the light on the owner's driveway. It wiped his driveway gate out, came down. The owner's property is about 100 yards north of this tower, and the fire came down right to the edge of his property, moved right to left, east to west, proceeded into the town of Ventura and just ravaged the town, destroyed hundreds of structures. Learned some lessons from that. Since then, we've been more sites, more cameras, PTZ cameras, backup power everywhere we can. And we're still doing that to this day. A few days after this fire, I got a call, email from a fire inspector from Ventura County Fire Department asking for the URL, and I gave it to him because it was still up on YouTube. Didn't hear anything directly back, but we heard through the grapevine that they found the video useful because it was the first video of the fire. So it was useful for their investigation. And the following June, every year in June, the Ventura County Board of Supervisors declares it Ham Radio Month. And in the proclamation, they specifically mentioned this video. So we got some good representation out of it. So after this, like I mentioned, we were hardening the network and expanding it. And the next year, in November, we got the Woolsey fire. Woolsey Canyon is on the border between LA County and Ventura County. My city, Simi County, or Simi Valley, is just over the county line in Ventura County. This particular camera is on the northern edge of Simi Valley, and it's looking in this view southwest. And in that corner, the Woolsey Canyon's about 4 screens off to the left. It's where it started, and it moved right to left, west to east. And again, another hot, windy day. It moved down, the fire moved down that hill and threatened the homes in the southwest corner of Simi. Ventura County Fire Department fought it off. The wind turned, fire went back up over the hill and down into Thousand Oaks, took out many, many structures there, continued south, went through Malibu, did a lot of damage there, and went to the ocean. We streamed this particular video to YouTube for over 36 hours, and Ben AI6YR has a large Twitter following because he puts out a lot of information about local emergencies, among other things, brush fires. And over the course of the 36 hours, we had several hundred people check in and out watching this video, and Ben got some good feedback about it. Says, you know, it's real-time data. We've done other fires too, nothing that major. The other big thing you can do with digital data is messaging, because future of MCOM is not voice, but data. Anybody who's had to transmit a full page of single-spaced medicine names or something like that knows how tedious and error-prone it can be. So you can certainly stand up standard email servers because they use standard SMTP, which is simple mail transport protocol, I think, but it's anything but simple. For us, there's a better way to do it, and that's Winlink. On email systems, you could use Thunderbird and web clients. There's lots of open source mail stuff out there, but for us, it's Winlink. Winlink and the mesh network are made for each other, and I'll talk about why. For those that may not be familiar with Winlink, it was originally intended for boaters using HF. And they originally used ALE radios, automatic link establishment. They're frequency agile commercial radios. Quite pricey, I understand. But since then, they've expanded into packet radio, robust packet, which is a protocol that SCS, the vendor of the Pactor modems, came up with. And I mentioned VARA, the FM, the software modem, which is available for both HF and FM. The Pactor modems tend to be fairly pricey. They're, I don't know, $1,500, $1,800. The license for VARA HF is, I think, $69 now, one-time purchase. You might think that, Pactor would run rings around something that's just written in software, but that's not the case. I recently saw some analyses. Some guys ran all of the various HF digital protocols through a ionospheric emulator. They could emulate fading, QSB, higher noise levels, and in a number of situations, number of configurations, VARA HF actually did better than Pactor 4, which is a real eye opener. So if you've thought about Winlink on HF, the VARA modems, a good way to go. RDOP is an older software modem for HF. In these tests, it did considerably poorer than pretty much everything else. So on VHF, packet radio, APRS, VARA FM, which can do up to 25 kilobits if you buy the right gear, or AREDN networking. I should take that recently added out. It's been a couple of years now. Obviously, it's much faster, but the really nice part about it is you don't have to define the path to the destination. You don't need to say you don't need to enter the intermediate digipeaters. And one of the cool things about Winlink is they have a full set of messaging templates that they're always updating. Incident command system, USGS, FEMA. In the USGS, there's a DYFI, did you feel it report, and reportedly USGS loves getting reports from hams over Winlink. I stole this from the Winlink website. It hasn't been updated in a while. So with my superior graphic skills, I updated it. WinMore is an HF protocol. It's been deprecated. It performed even worse than RDOP. They're not even supporting it anymore. But on HF, there's VARA and RDOP. There's VARA for VHF and UHF packet, or also for packet. And that's the layer where ham radio networking goes. So this is Winlink Express. It's the email client. It looks like a plain old email client, but because you have to specify the path and the protocol, how you're going to send your message. Is it going to go via packet, APRS, the mesh network, whatever? Creating a message is pretty straightforward, but routing it is a little more complex. Anytime you send a message, it brings up a session image and it shows you the progress as it sends it. It's the same for packet and whatever, HF. But I wanted to show you this. The size of the messages you can send, message and attachment, is limited, obviously, because if you sent a large message via HF, you'd still be sending it days later. I sent this one, 22 kilobyte message, which I think is close to the maximum to a Winlink post office sitting on the mesh network 3 hops away. And you can see that to get connected, transfer 22 kbytes and get disconnected was 10 seconds. This thing moves traffic like crazy. Other things you can do, if you have a weather station, you can put it on the mesh network. Excuse me, I have a Pete Brothers Altimeter 2100, very nice device, but it does not have a web interface. Took the serial port out through a USB converter to a Raspberry Pi. And this software is called WX. It's open source, supports 3 or 4 different OSs and hundreds of different environmental sensors, weather stations, you name it. It's recommended if you want to put your weather station on a web page, and it will also push it out to the internet if you have internet access. It's not all about MCOM. We've spun up a Scrabble server and played a little bit. Here's a tank game for you. I get the pants beat off me every time I play it. It's a lot of fun, but I suck at it. And once in a great while after the Wednesday night nets, we play a couple hands of poker. So the equipment, what's out there? Mostly designed for hard outdoor use. There is one notable exception I'll talk about. And as a result, it's weatherproof and it's PoE, power over Ethernet, which simplifies the cabling. I mentioned about the hardware. I can't believe they sell this sophisticated hardware so cheaply. I mean, it's insane. Most of them have built-in gain antennas, 2 gain antennas, and there are a couple that don't, and we'll talk about that. And I mentioned the MIMO and the 802.11n. 802.11n is so sophisticated that if you wind up getting multipath to the destination, it doesn't destroy the data, it just combines it from the different paths. And the MIMO gives you some phase resiliency and like I said, doubles the throughput. Just a quick note here, if you're thinking about running off to eBay, the previous generations of gear only had 8 megs of flash or less and 32 megs of RAM. As OpenWRT adds features and devices, its source code grows slowly. So the AREDN firmware, which is based on it, also grows slowly. And so far, they're able to wedge the image into the older devices, but it's getting difficult. Also, don't purchase if they're not MIMO. They don't play well with the modern devices. If you're not sure, on the AREDN website, they have a supported product matrix, and they've flagged all the devices that they don't recommend for new deployments or new purchase. Additionally, in a recent network-wide stress test we did, we found that some of the older devices, the ones with the slower CPUs, had trouble keeping up with the larger volumes of routing traffic. So this is old school. Linksys WRT54G. This was probably running broadband Hamnet. Only 4 megs of flash, not waterproofed, obviously. And in spite of having 2 network cable or radio cables there, coax connectors, it wasn't MIMO, and didn't support 802.11n. So if you have a pile of these laying around, I don't know, hold the door open with them. So these are the nanostations. A lot of people got started with these for 2 gigs and 5 gigs. They work very well out to 10 to 12 miles, assuming you have line of sight. For a couple of reasons, I'm not recommending them for new purchase. I need to put a star by the M2 now, based on what we've learned, and I'll talk more about that. Here are some things that are a little beefier. On the left is Ubiquiti PowerBeam for 5 gigs. They make a 2 gig version too, but we're not using 2 gigs much anymore, and I'll talk about why. So anyway, you can get the PowerBeam in the 300, 400, and the 620 millimeter scare your neighbor size. And on the right are the Mikrotiks, which they've been supporting for about 3 years now. The Lighthead Grid 5, 5XL, and HBXL. Very popular with guys who are retrofitting their Go kits for digital or making all native new digital Go kits because they're quite light and very low wind resistance, obviously. It doesn't really apply in Southern California, but when I talk to groups in the Midwest, I give them the caveat that if you have heavy icing, you might want to skip the Mikrotiks because they're not as robust as the metal dish on the Ubiquiti. Here's some TP links. Excellent gear. They've been 64 megs of RAM forever. I run an old version 1 CPE 210 at another site as a backup, and it's still running. The 5.8 gigahertz, I'm not recommending, and I'll talk about why. The CPE 610 for 5 gigahertz is an excellent device. It's been discontinued. The replacement is the CPE 710, and it's not yet supported by AREDN because it's not yet supported by OpenWRT, but I understand it's moving along and we may see support for it in the near future. So obviously this is not waterproof, not meant for outside use. This is a Mikrotik router, 5-port router. Very handy when you put AREDN code on it. The problem is all of the IP devices on a mesh network run in the 10.0.0.0 network and can't be moved. And obviously that doesn't play well with your home network, which is usually 192.168. whatever. Well, fortunately, the AREDN code can make them play nice together. This is a graphic another ham did for me. Port 5 there runs PoE up to your outside node and also the DTD protocol. That's device to device. Port 1 is your home network connection. With that all set up, anything on port 2, 3, and 4, could be your computer, could be your VoIP phone, whatever. Those 3 ports have access to both networks, internet and the mesh network, appropriately firewalled. This makes it so you no longer have to run 2 computers in the shack, one for mesh and one for everything else. That was really annoying. The Mikrotik HAP AC Lite running AREDN has a number of other features that makes it useful as heck. Pretty much anybody who puts a node up outside on their house, this is pretty much what they buy second, almost 100%. At $50, it's a steal. Okay, a few outside examples. Home setups. Left is K1 GGS. 2 nanostations pointing at a site, I don't know, 3.5 miles away. Y2. There's a 2.4 and a 5.8 gigahertz user access point up at the site. So he's got dual connections. If one of those links goes down, he still has connectivity. We try and do this at every served agency we can, where we have either a dual access or multiple sites visible. On the right, you see a Nanostation on top and a Mikrotik dish down below. I didn't mention it, but the Nanostation is the only device available to us that has 2 Ethernet ports, a main and a secondary. You run your PoE Ethernet cable up from the shack to the main, then loop it out of the secondary into your second node. So it feeds through not only PoE, but data. So you could have a 2.4 and a 5 gig access or node on the same tower. And if you happen to live in an HOA community, this is the solution for you. That's a Mikrotik Light Dish Feed 5 for 5 gigahertz at the feed point of an old satellite TV dish using an $8 universal LNO adapter there. Works quite well. You can get 23 dBi gain out of this whole thing. And your neighbors will never notice that that dish is not pointing at a synchronous satellite. So a lot of the stuff I've talked about, a lot of the equipment, just like a Baofeng handy talkie, you wouldn't put it up on a repeater site in production, not appropriate. This is the vast majority of the mesh network sites on hilltops use at least one of these, if not two, or maybe even three. This is a sector antenna. It's so called because it covers a certain number of degrees of the compass. 120 degrees are the most popular. They do make 60, 90, and 180s. It's MIMO. There's two antennas in there, vertically and horizontally polarized, and clipped on the back is Ubiquiti Rocket M5 for 5 gigahertz. And you can see the SMA jumpers there, connecting both radios in the rocket to both antennas. And here's another setup. This would be considered a small site. This is in North Orange County. Sector antennas for 2.43 and 5 gigahertz. Pan-tilt zoom camera and a bullet camera. The bullet camera is watching the batteries and solar panels behind us in this picture. There's no AC power at this site. It's a quarter-mile hike off of a dirt road in North Orange County someplace. Here's a medium-sized site. This is the one I take care of on Chatsworth Peak. The yellow container, the stuff on the left side of it is county gear that we don't care about. There's a 4-pole there for a UHF repeater and a UHF Yagi for linking the system. This is the PVAR K6 PVR system. On the top of the tower is the Omni for the 2-meter antenna, or 2-meter repeater. And we have 4 sector antennas and 2 dishes. Let's see. This is a quiz. Upper right is a 2 gigahertz mesh node. Upper left is a 3 gigahertz mesh node that I use for linking 3 local sites together for a local network. On the left side down is the let's see. Oh, that's a 2.4 gigahertz part 15 access point for some commercial use. And the sector antenna on the tower, the front of the tower, there is a 5.8 gigahertz for the local users. Small dish is a test network that's hardly ever used. The large dish is a 5.8 gigahertz rocket dish with a Rocket M5 behind it. That's pointing west into Ventura County. That's our county backbone link. You can't see it, but behind those rocks is a set of stairs, and buried next to the stairs is a set of Ethernet cable that go up to a much larger container where there's several repeaters and also a 3 gigahertz dish pointing east to Verdugo Peak. This is the darn site on Verdugo Peak. Looks impressive, and it is, but only a small part of it is the mesh network. I think it's the 3 topmost sector antennas. There's one for 5 gigs pointing south, one for 5 gigs pointing west, and a 2.4 gig pointing west also. On the telephone pole, you can see 2 dish antennas. They continue the backbone link to Mount Wilson and Mount Disappointment, I believe. And here's what you genuinely call a large site. This is a commercial site on Pleasants Peak in Orange County. The owner is ham friendly, and one of the AREDN developers lives down there. So he had a number of years to develop this. Everything in yellow he's put up there. And down below where you can't see it are dish antennas pointing at different points of the compass. This is a central hub. So Eric KG6WXC lives in Port Hueneme, wrote a network mapper. It goes out and crawls the network. And fortunately, in each node, there's a JSON file, which is a text file, XML, has all the vital data about the node, not only the hardware and the software, port configurations, routes, and route qualities. And he records that into a, I think it's an SQL database. I'm able to extract CSV files out of that, and I do a lot of admin maintenance, and I can see who's running old software and old hardware and shame them into getting something newer. But if the node has latitude and longitude loaded into it, and most do, he can place it on a map. And because the software is open source, a number of people around the world are using it. And I've grabbed some screenshots, some of them to look at. This is Oregon. Orange is 5 gigs. Purple is 2 gigs. Let me see here. This is a test. Pink is 900, blue is 3 gigs, and the gray have no RF. Those would be HAP AC lights. Here's a Bay Area mesh network. This didn't exist when I gave my presentation at PacificCon in 2019. So props to them for rolling this out in the last couple of years. The city of San Francisco has been very cooperative with them, letting them put nodes up on pretty much any city facility they want. They're working now at pushing it down south and east, making good progress. Here's Southern California, the big daddy. At the time I took this screenshot, I think there were 425 nodes in this section of the map. A lot of them are ground stations, a lot of them are hilltops. These next few slides, I've just created in the last couple of days, and they are not complete. My apologies for that. Out here in Ventura County, here are the nodes, the hills. Excuse me, these are the sites that have user access points on them. Most of them are 5 gigs. Some of them also have 2 gigs. And you can see that we're getting there. LA County was kind of late to the game. They're playing catch up a little bit, but making good progress. Loop Canyon, Verdugo Peak, Wilson. And by the way, a number of these sites have more than one access point on them, pointing at different bearings. This is incomplete, I know it, but Snow Peak, Sunset Ridge, Yucaipa, Hospital in Loma Linda, you can read the list there. I did not have time to get down into San Diego. My apologies for that. But I did map what I had. And, you know, it took 40 years for us to get the FM repeater coverage that we have now. Everything on this map here did not exist 6 years ago. So we're making good progress. There's a lot of work left to do, but we are making good progress. These are future user access points that I know about. I know there's more going on there. Hauser Peak. Oh, that should have been in progress. No, it's not in progress. It's planned. PV is in progress. Palos Verdes. Norm is working on the 69 Bravo Gila spot and maybe a link up to Saddle Peak. And all of these would be linked into the backbone, so they'll all be accessible. Oh, here's a duplicate. Sorry about that. Where do you get info? AREDNmesh.org is the AREDN website. They have a full list of supported products, and don't buy anything until you read up on what's supported and what isn't. More and more products are coming out with 802.11 AC. They're not yet supported by AREDN. Maybe by the end of the year, they'll be in beta. Just be careful what you buy. Software downloads, obviously. They put out a production build, I don't know, it's approximately annually. I think we had one at mid-year. But in between the production releases, they have what they call nightly builds. The build process runs nightly, but if there's no new patches committed, there's no new software generated. But a lot of the nightly builds are minor fixes and stuff. A few of them lately have been quite significant. I encourage everybody to run the nightly builds. They're stable. There's a lot of them in production. How-tos, FAQs. Steve, AB7PA has done a wonderful job in getting his arms around all the documentation, pulling it into a wiki. If you're interested, I would recommend at least skimming the documentation. It's pretty much soup to nuts in there. They have forums on the website. There's various topics, deployments, discussion. There are regional forums for states or localities. California has, I don't know, 6 or 7 sub-forums. The Facebook group is pretty active. There's over 1,500 members there. A lot of videos on YouTube about ham radio networking. The little asterisk there is to remind me to tell you that this stuff is evolving rapidly. If you run across a video about ham radio networking that's older than a couple years, I'd recommend taking a pass. Find something a little newer. We have an email list in Southern California. I think we just went over a couple hundred users. It's not super active. If you're interested and like to join it, just ping me. I have a short beginner's guide PDF if you're interested in distributing it to your ham friends. And I have a PDF version of this presentation with all my verbiage loaded into it. And if you want that, just let me know. Any questions? I didn't mention, we put Raspberry Pis at each site. And this is the one on Chatsworth Peak. You can run video, but running video of something where a field where all you see is the grass waving is pretty boring. So what we do is we take a screenshot every 5 minutes and put it up on a website. This is the Raspberry Pi at Chatsworth Peak. Additionally, we run telemetry. This one only has inside and outside temperature, but we do also monitor at other sites AC power status, battery voltage, etc. So all sorts of things you can do. See, Don asked minimum cost to get started. Well, I'm not, I didn't mention it. I'm not recommending the nanostations for 5 gigs anymore because the FCC is going to grant Part 15 access to the whole band. So over time, the noise floor is going to start coming up. So I'd recommend if you're buying something new, buy something with more gain rather than less to kind of future-proof your purchase. That being said, one of these small dishes is, I don't know, between 80 and $100. You have to buy outdoor Ethernet cable. That's another cost depending on how long you run it, but it could be $30 or so. And you really want the HAP AC Lite, which is $50. That's it. How do we access your PDF? Norm, I'll send you the Google link to it. It's up on Google Docs and you can distribute that. Just remind me. What are the settings for Grandstream for VoIP to VoIP direct dialing? I had to look them up and I have them bookmarked. I don't have it memorized. Sorry. Oh, good question. What about the use of 3 gigahertz being sold to the cell provider? How's it impact? I didn't talk about that. Here's the deal. I mentioned it to Norm when he was here the other day. We are losing at the beginning of sometime in early 2022, the upper 50 megahertz of 3 gigahertz. They're auctioning it off to the cell providers because it turns out it's an excellent band for cell phone usage. I'm sorry, I'm reading. I shouldn't get distracted. My bad. And I was telling Norm that the FCC expects to get in excess of $10 billion in bids for that the 3 gig segment. The future of the rest of the band is up in the air. The FCC had talked about also auctioning it off, but they got a huge pushback from all directions. And the last time I heard is they're rethinking that. So we have at least a couple years usage. I wouldn't go out and buy new 3 gigahertz gear. It's expensive and hard to find anyway. But if you've got it, use it. I wouldn't even worry about it. I was asking about supported hardware. It is under ardenmesh.org. It's in one of the drop-down menus. Can the AREDN software be configured to run under Part 15? You certainly can. Yeah, it'll cover all of those channels. The only issue with it is you're fighting everything else on that. Prior to the AREDN code gaining the ability to move out of Part 15, I had a link, 3-mile link to another ham at the other end of town, and we were on channel 1, I think, and there were 45 user access points visible to us between him and me, and the link quality was never better than about 75%. And we adopted the beta software that let us move out to channel -2, which is the ham band. The link quality has jumped above 95%. Oh, if you don't have access via RF, how do you link via the internet? There are modules you can load in the AREDN software, a tunnel client and a tunnel server. Typically, if you're like me, in this case, I do have an RF link. I have a HAP AC Lite in the shack and it has internet access. I run the tunnel server. Somebody else gets the tunnel client and they have to have internet access. I give them a password and a login, and their tunnel client connects to my tunnel server, and they see the network via my link. You just have to install the appropriate tunnel module in your node, and you have to have internet access. All units have to be flashed to be in the Part 97 band? Yes. The only link I can hit in San Fernando Valley is Verdugo Mountain. That is correct. There may be other nodes in the future, but I don't know of any firm plans for that. Verdugo Peak nodes cover 80% of the valley. There's a few limitations. Who is now the lead person for planning and implementation for San Diego County? That is a great question. Andre K6AH used to do a lot of that. He's had some serious medical issues. I think he's kind of stepped back from that. So I don't know. You guys get together and elect somebody. I'm 150 miles away. Somebody says OAT would be great. Yes and no, it has wide coverage, but we want to move towards a cellular concept. If I was going to use OAT, I would use it as a backbone link down to lower sites like 6 and 7 story buildings, you know, and put a link to OAT up there and a sector or two. That's what we do in the West LA VA. They have a 20-foot tower on top of a 2 or 3 story building, and we have a 3 gig link to Mount Wilson there and a couple of 120-degree sector antennas. Does Keith Kaysen have this equipment running in Redlands? Keith is awesome. He has at least a dozen sites running. He is responsible for all of the high-level sites down there. Props to him. Yeah, development for Go kits for Baker to Vegas. You know, Baker to Vegas would be an excellent, and I know they've started experimenting with limited AREDN and non-AREDN microwave links between the various hops there. I'm not involved with Baker to Vegas, but a lot of the guys are in the mesh network, so you could get more details from them. Maybe ask on the mailing list.
Hey, Orf.
Yeah.
Just as an aside, and since we were mentioning it, and you were just mentioning the application for that, these little Mikrotik lighthead grids, they lend themselves very well to portable operation, Go kits and stuff like that. You put this up on a 15-foot fiberglass tripod mast and run the Ethernet out. It comes down through one of these legs, and you can start linking these babies together. Here in Culver City, we are including these in our Go kits now, so that instead of using packet to transfer our messages back and forth between different emergency command sites, these will do it over the mesh in a very, very small amount of time, and it frees up our Go box radios on 2 meters and 70 centimeters for voice traffic, which we can minimize, so we don't have to use packets on 70 centimeters to transfer our data. These things are super fast. I demoed this at the August 21st Operation Blackout drill that we had, and everybody else was doing something between voice and packet to transfer their ICS 213 message traffic. We were 100% on the mesh, and we were just sitting back, typing a little bit here and typing a little bit there, and we could have handled so much more traffic.
Hey, Kevin, let me see the back of that dish. You've got the optional alignment. Yeah, that's additional. If you don't buy that, you get to strap it on a pole, and you don't get to point it very well. I'm going to have to get one of those.
They're
That's
cheap.
cool.
They're like $6 a piece.
Oh, really?
Yeah,
Sweet.
I buy them in 6 packs.
Yeah, this is good stuff, folks. You can move a lot of data with this, and if you like computers and you like a ham radio, this is a wonderful combination. Oh, there's a question for you.
Oops, I did not see the question. What is the question?
They're $15 on Amazon. Where do you buy the back?
Oh, I'll have to look that up. Let me look for an answer, and I'll try to get back to you and throw it in the chat buffer.
What covers Castaic and Santa Clarita? The node on Loop Canyon covers about 75% of Santa Clarita Valley. I'd have to look at the coverage map and see if Castaic, if it reaches all the way up. Yeah. Here. This is for Neil.
Yeah, I'll unmute here. Yeah, I tried the one that's on the KG6WXC map. It's called Magic Mountain,
Yeah.
but was unable to hit that from Castaic, the Castaic Park area. And I was up pretty high by the dam.
Go to heywhatsthat.com and put in your Latin lawn from that site and see if it has a view of the Loop Canyon, which is right next to Fire Camp. It's above Fire Camp 9.
Is that the one that's called KCBFGLA Magic Mountain?
K6BFG, yeah.
Okay, yeah, that's the one I tried, but was not able to see it from Castaic Park.
Yeah, there may be something in the way. Yeah, the line of sight is a real downer.
Yeah, there was a little hill that was blocking some of that range, and I could see some towers, but I wasn't exactly sure which one was Magic Mountain. So that was probably the one behind the little mountain of dirt. But
What were you using for your node?
Just one of the 5.8 Ubiquitis that you no longer recommend.
Yeah, they have about 13 dBi gain. By going to one of the dishes, you can pick up another 10 dB. So it might be worth a try.
Yeah, that Mikrotik looks good. Might have to move up to that.
Yeah, they use a lot of nanostations in the Bay Area. And I think after my PacificCon presentation, they might be retiring a lot of them. And by the way, I don't know how many of you pay attention to it. As our networks grew over the last few years, we discovered a scaling problem. We wound up with packet routing storms. They would loop round and round and bring the performance of the network to bring it to its knees. And a ham who's a software coder in the Bay Area spotted the issue and put a patch out. We tested it in Ventura County, it looked fine. We pushed it out in a nightly build and encouraged everybody to get it. And on the 30th, we did a massive linking tests. The San Francisco network, gosh, all over the place. Southern California, Hawaiian Islands, a lot of places in the Midwest. I even surfed a guy's website in Italy on the mesh network. Obviously, they're all connected to the internet. Anyway, we got up to 1,100 nodes and the network was stable, which was good news. It's no more packet storms. What we did discover is a lot of those nanostations fell over and died because they have one of the slowest CPUs in them of all the gear we use.
Uh-oh.
Hey, Kevin.
I found the price. It is $17.50. The first time I bought them, they were, I'm almost certain it was $6.95 a piece, but $17.50. I didn't even notice it. I just bought the 6-pack and here they are.
Yeah.
I've still got them in a box in my drawer back behind me.
Kevin, you remember the older nanostations, the XMs only had 32 megs of RAM?
Yes.
And everybody was happy when the XW hardware came out with 64 megs of RAM?
Yeah, sort of. There was issues both ways on the XW versus XM, but yeah.
Yeah, it turns out they both use the same old slow 400 megahertz CPU.
Oh, really?
So you won't run out of RAM, but your CPU will fall over and die. Anyway, we're doing mesh gossip here. Yeah, one of those.
This is gonna die, huh?
Yeah, well, eventually. Hey, pop the cover off and let them look at it.
Sure.
Yeah, there's the main and secondary and a reset button. They're really useful devices for local coverage. I don't want to badmouth them, but just be aware that as networks grow, their lifetime may be limited.
Kevin, could you hold that up again? I got you spotlighted now. Yeah, thank you.
Oops, let me turn that over. You can see main, secondary, and power. The power is just a reset. Excuse me, that says reset. My 62-year-old eyes. reset main and secondary.
Yeah, show
Really?
the back of it. Show the back of it. That's where you clip it to a pole. A word of caution, don't use tie wraps because eventually they will break, it will turn upside down and the thing will fill up with rainwater. Ask me how I know.
Yeah, this is my other project. Here in Culver City, I'm a little behind Orv and his outfit, but you can see there, this is a PTZ camera and a fixed camera. Those, a bullet camera, those are waiting for deployment.
Somebody asked if Kevin was here. He wasn't sure if he could make it, and I don't see, or I'm sorry, Keith. Yeah. Keith's your main man down in that area. Somebody's asking if the model for the Mikrotik dish is the LHG5. Yes, it is.
There are different sizes to these LHG.
I've never seen that big one before. I think the big one's what, about 110? You're muted, Kevin, or something.
Well, I got another oddball question. One of the ways I check to see if I've got RF coming off an antenna is I've got a little incandescent bulb in the middle of a dipole, and I cut the leads on the incandescent bulb to the appropriate length, like 6 inches for 70 centimeters. Is there anything like that you could hold up in front of a dish or the sector antenna to let you know that RF is coming out?
Wow, that's a great question. I'll have to research that.
Yeah, I've got these little, I demonstrated, except I know that my camera turns off when I expose it to RF. But
There's your answer in the chat, Norm.
Oh, okay. That's the cool thing. See, I've got these little guys. And if I hold that up to an antenna, 5 watts will light it brightly. Okay.
Yeah, well, 600 milliwatts probably would not, but yeah, that's a good idea.
Well, 600 milliwatts might not, but at the focus of a dish, it might.
Good point. Good point. I imagine a microwave oven leakage detector is pretty sensitive. So yeah, that might work. I'll have to get one of those.
Yeah, you warned me, so I'll pass the warning on to everybody else. If you're using a dish, do not stand in front of it.
I was telling Norm yesterday that the rocket equivalent from Mikrotik is the base box. And on 2 gigs, they make one that puts out 1,000 milliwatts, 1 watt, which is 30 dB. And they have an accompanying 30 dBi gain dish for it. That's 1 kW of ERP. So you definitely don't want to mess around with this stuff.
Will it work on 5.8? I don't know.
It says 2459 megahertz. I bet it's broadband. I don't know if it's broadband enough for 5 gigs.
Yeah, what's the link there?
5 milliwatts per square centimeter. Interesting. Well, $27. It's worth messing around with.
So okay. So apparently, it's calibrated for 2459 megahertz. My guess is it would respond. You'd get some indication, but you wouldn't have the calibration.
Or
yeah,
are the mesh antennas and these field strengths are going to have to be documented for the FCC's requirements for us to document all of our antennas as ham radio operators?
Yeah, I don't think they mandate actual measurements. They let you do calculations.
Yeah.
Good question though, Phil.
Calculations, and they will also use modeling data from
right.
Easy.
Right.
But are they going to cover and require us to do the documentation on all of our mesh stuff too?
Well, there's two different requirements I'm not up to speed as much as I should be, but there's one for antennas where people can get exposed and one where they have no chance of getting exposed. Something like that. I need to read up on that.
Mm-hmm.
Do you know the date on that where we're going to start being required with it to do that?
I don't.
I don't either. I'm like, I've got so many antennas in my yard. I'm like, oh God. Hey.
Well, they were going to grandfather us for everything that was there prior, and then just work us in over time to have to document that. But anything new has to be documented now.
You know, I imagine for a lot of these mesh installations on hills, once you've done the calculations for one site, it's pretty much boilerplate for all the others. Let's see, outdoor ubiquities. Well, I did notice the Ubiquiti PowerBeams are starting to get hard to find. I think Ubiquiti is starting to ramp down their production of their, I guess we could call it legacy 802.11n stuff now in favor of 802.11 AC. Let me see how I can answer this. If you're going to be operating ground level, any one of the dishes will work. Honestly, Ubiquiti or Mikrotik, they're all good devices. 5.8 gigahertz sector antenna. Well, it would be the Ubiquiti. Mikrotik does make sector antennas too to go with their band box. I have one of them. Haven't deployed it yet. The nice thing about the Ubiquiti gear is the base box. Sorry, you can buy it integrated into the antenna housing. There's no external radio, but that's nice. That's compact. And typically you'd use a sector antenna on a hilltop where you need to cover parts of a town or all of a town. Okay, Norm, I think we can pull the plug. Oh, Sunset Peak. I have no idea. Bob, NT5A. There is no cookbook situation. HeyWhat'sThat.com is a quick and dirty site where you can put in your lat line and your elevation, and it shows you what you have line of sight. Now, the other situation is even if you have line of sight to Sunset Peak, is anything in Sunset Peak pointing back in your direction. So you probably need to know the local setup too. I don't even know where Sunset Peak is. See, I'm out here on the west end in the boonies. You know what? Do we have time, Norm? I could demo that.
I have time.
Okay. Who was that? Oh, NT5A. Give me, oh, never mind. Let me ask him. Claremont Upland. NT5A, is your address good in the call book? I'll get your location there. Radio call sign lookup. NT5A. Oh, it says San Dimas, is that right? Let's see. Let me share this. Let's see here, share. Let me create a new panorama here. Okay, there he is at San Dimas. Is that? Let me see here. So we'll assume elevation of say 25 feet. and put in NT5A. 5A. There are other sites that will do this. Ubiquiti has a site, and there's a couple of others that are popular. So this would give you the coverage here. Here, let's take a look at this. Does look a little limited, although let me see. Where is Sunset Ridge? See if Google knows about it. Sunset Ridge Trail. Let's see, where is it? Let me back off. Mount Low. What does the terrain look like there? Woodbury. Okay. I'm not sure. I'm going to stop sharing, but that's how you use it. You can determine, for instance, if the site was here on Johnstone Peak, you can see by the profile that yes, you do have line of sight. And if you click down here on Compute LOS, it says your antenna has to be at least 4 feet above the ground. Of course, that assumes there's no houses in between. So anyway, that's how you do it. So asking about internet outage, the plan is for messaging, use Winlink to move your mails out of the area where there's an internet outage. If it's an earthquake or something, that could be 20, 30 miles. You could do that on, well, anything that reaches out that far. And if it's either farther than that, they do move messages up to OES in Sacramento. I'm sorry?
I was getting some packet loss here. I don't know if it's local or if it's at your end. But you were mentioning that it moved things up to OES.
We're doing a remodel, and I'm to do a remodel.
There we go.
Yeah, from the Lost Hill Sheriff Station, we moved some things on Winlink on HF to a station in Las Vegas and a station in Colorado, and we satisfied ourselves that we could do that. That was using VARA.
Nice. Well, Norma, I better bail out of here before my wireless dies completely.
Okay, most of that worked just fine. There was just a little packet lost just when you were explaining about moving stuff up to OES and out of the area. But HF is the way to go if you need to get out of the area to somebody with the internet.
And I recommend, everybody get Winlink Express. It's free. Register it. Use it occasionally so it doesn't expire. Just get familiar how to move it. You can send email out through it over the internet, even if you don't have any RF connections, just to get familiar with it.
Okay. Well, thanks, Orv. I'll leave this session up and I'll stick with it as long as I can. And if I need to leave, I'll make somebody else host.
Okay. Thanks, guys. Appreciate it.